So what I want to talk about then today is the hierarchical analysis of variance. Hierarchical research designs are stupid, don't do them. But I'm going to tell you it happens. My favorite example of this is a friend of mine, John, and when he was in his fourth year, I was just started graduate school, we were friends in undergrad, and he designed this experiment, and he had no idea he had a hierarchical design, which is a really bad, you'll see in a second why, kind of research design. Sometimes you have to do it, but it doesn't mean you have to like it. All right. So usually all of our factors, right, our independent variables, are crossed with each other. Meaning, well, like look at our example here. All the levels of A occur with all the levels of B. And you might be thinking to yourself, well, how the hell else would you do it? It's a good question. Well, you'll find out today, and you'll find out there's a lot of bad ways to do this, too. So each level of A occurs with each level of B, for example, right? Just like I just said. This is what we usually have, and this is what you will see almost always. And I'm not talking about subjects here. Subjects are often nested, right? So if we have independent groups, we have subjects within A, for example, with different subjects in A1 that we have within A2. But that's not what I'm talking about here. I'm talking about our independent variables. We kind of mathematically treat subjects like an independent variable, but they're not the same as any other independent variable. So sometimes, however, things are different. Sometimes, and this is typically the case because of circumstance. Like you have no other choice, and this is very often done in, these kind of designs I'm going to talk about are often done with in sort of field experiments. They aren't things you would do in a lab, unless you're my friend John who screwed up his honors thesis. Okay, so here's an example. This is a real research design from a real study. It's a clinical trial for a drug dealing with pain in burn survivors. Okay, that's what this is. This is about a clinical trial of people who were burn survivors. And this was something that a friend of mine actually consulted on this. One of the things you can do as a psychology graduate student is if you're good at stats, you can sell your expertise to people who aren't. And you can sell it for expensive because they aren't. So, you know, once in grad school, I made $200 in 10 minutes because I said, no, you've done this wrong. To a couple of guys, ophthalmologists doing work on at the eye bank at U of T. And it was literally downstairs from our lab. I went downstairs and I looked and I went, yeah, but you've designed this experiment wrong. I mean, I can analyze it for you. I did it. The guy said, how much is that? I said, it's $200. I said, oh, and then he paid me. Right, so my friend Todd, say friend, wasn't, some things have come out about Todd. But I know he did this because he, in fact, was our TA in grad school stats in our first year. And he taught us about this kind of design. And he showed us that in this case, we had 3 different hospitals in Toronto, and we had 6 different pain drugs. Now, happily, there aren't enough burn survivors, right? You don't want people, that's not good. Being burned all over your body is bad. So there weren't enough subjects, basically. So what they did is they had 6 drugs in 3 hospitals. But if you note, they only did like 2 drugs in hospital 1 because they didn't have enough subjects in each group, in each hospital. So group 1 is drug 1, hospital 1. Group 2 is hospital 1, drug 2. Group 3 is drug 3, hospital 2. Note that hospital doesn't occur with every kind of drug. There are 2 drugs within each hospital. 1 and 2 in hospital 1. 3 and 4 in hospital 2. 5 and 6 in hospital 3. And this was because they had no choice. So they didn't have enough subjects, which again is kind of a, you don't want to hear about too many, people in horrible pain. So maybe that's nice. I don't know. Nice isn't quite the right word. And they don't have tons of money. They don't have an infinite amount of money. And this was in the early 90s when there were a lot of cutbacks and things. So it was like, this is the experiment. We have money. We have this many doses. We have this many. That's all we have. Design the experiment. And Todd looked at it and said, well, you got to do it this way. Because you might say to yourself, just ignore hospital. And then you just have a simple one-way analysis of variance, except that don't you think hospital plays a role? Sure, every hospital is a little bit different, right? Some hospitals have better food than others, or a nicer staff, right? So that's going to affect people's recovery too. So you have to bring that into the model, but the problem is it's confounded, because drugs are nested within the hospital. But as Todd said to these people, he said, I can't analyze these data without including hospital, because it would be disingenuous. Okay. So the 5 burn survivors per group. So as I said, they wanted to have enough people to look for an effect, but they didn't have too many. And look, if you only had, so we've got 30 people across all of Metro Toronto that are in this clinical trial. That's it. Okay. Questions on the design? Make some sense? Okay, so let's see how it works. This is a really weird design. Now, the nesting is the same as nesting of subjects. We just gotta change it a little bit. We've got hospital at the top of the hierarchy, and there are how many hospitals? Well, there are 3 of them, so we're gonna have 2 degrees of freedom for hospital. And then we have drugs within hospitals. So far this looks just like before, except instead of being subjects, it's drugs. D minus 1 times 3. Within each level of hospital, there are 2 drugs. So D is 2, not 6. Yeah? Okay. So it's 2 minus 1 is 1 times 3, that's 3. And then subjects are nested within hospital drug interactions. N minus 1, so that was what? I said 5, right? So it's 4, right? Times 2 drugs in each hospital, times 3 hospitals is 24. So it's also, remember, it's not subjects within drugs within hospital. And that's just a matter of notation. It's just drug-hospital interactions. Ideally, you don't want to do this. Ideally, you'd want, if you're going to put hospital in the model, you'd want hospitals and drugs crossed. But we just don't have that number of subjects. Because with 6 drugs and 3 hospitals, 6 times 18, you'd literally need 3 times as many subjects here. And we just don't have that many subjects, which again is probably a good thing. So we're going to test both of these effects, hospital and drugs in hospital, with the subject vector. So when you do the analysis of variance, you would do that. Now, if you were doing this in SPSS, and you can do a design like this in SPSS, you have to specify the whole model. And I think, I don't know if I've posted one yet about how to do that, but it's pretty simple. But you do have to know all the sources of variation. There's a reason I'm teaching you all this stuff. It's because when you get a complicated design like this, and you just told it, oh, it's a drug by hospital interaction, it would spit it out and go, no, it's not, and it would just stop. You won't break it. You can't break it. But it wouldn't work. You'd get nonsense. So if you specify the model properly and say that we have hospital, drugs within hospital, and subjects within drug-hospital interactions, it'll do it right, which is what you want. Okay, let's do another one. So this is going to have, I just picked 3. There's going to be 3 subjects in each group. Okay, so we've got, let's see, we have 3 factors. Looks like C's repeated, doesn't it? Everybody gets every level of C, don't they? Let's see. So remember, you always between subjects within, and we'll start at the top of the hierarchy and move down. So what's our between factors? A1 and A2 are, right? Different subjects with different levels of A. So A1, A2, and A is a between subjects factor. So is B. Can you talk about B on its own? Don't think so. You have to mention that it's within A. Because B1 and B2 are in A1, and B3 and B4 are in A2. You can't talk about B without talking about the level of A that it's nested in. You just can't.
Okay. So let's just put that over there.
So we have nesting now, and we also have a within subject variable. I'm just showing you that you can make these more complicated. So if you remember Yates' order, the idea of between, subjects, within, and always start at the top of the hierarchy. That's the final thing, and then you know everything about Yates' order. So we're going to start at the top of the hierarchy is going to be A, right? Because A is a between subject variable, and it's not nested. So we're going to go A, and then we're going to do B within A. I'll show you all in a second. And then we're going to talk about the subjects, and then we're going to do C. You don't want a design like this. You really don't. Okay, here's what it comes out like. So, like I said, we're going to list A first. There are two levels of A minus 1 degree of freedom. And then we're going to do B within A. Let's not worry about the degrees of freedom right now, for the rest of it. And then we're going to say subjects within AB. Note we don't go B within A by A. That doesn't make any sense. You can't interact the factor by itself. So, S within AB. And then C, now it gets easy. C by A, C by B within A, C by S within AB. Now let's do degrees of freedom. A was easy, you did that already. Now B minus 1 times A. Within each level of A, there are two B's, right? So that's 2 minus 1, which is 1, times 2, which is 2. Did it right. N minus 1, how many subjects did I say? Did I say 3? Is it 3? So that's going to be, 2 times 2 times 2 is 8. Okay, we're doing okay so far. Well, C is going to be easy. C minus 1. C minus 1 times A minus 1, C minus 1 times A minus 1 times, times B minus 1 times A. 7. Total number of degrees of freedom we have is 23. We have 6 cells, is that right? No, 8 cells. And we have 3 observations per cell, which is 24. Hey, we probably did it right. We probably did it right. Because the degrees of freedom probably aren't going to come out right if you did it wrong. And you test always, you would divide mean squared for A by mean squared for S within AB. And again, if you were doing this with SPSS and specified the model, it would know what to test with what. I would always double check that. Because maybe you forgot to say that, oh, this is a fixed factor, this is a random factor. And if you did it with, I don't know that you can do this with PSPP. That might be too complicated for PSPP. Okay, questions? Do you see how I did this so far? I can tell you that on the final exam there will be like 3 of these. Not like this necessarily. They'll be harder than this, but one of them will be harder than this for sure. There will be 3 or 4 time of these where I give you a design and you give me the source of variation degrees of freedom. This is something you can get better and better at with practice. It's literally just make up examples and practice. And this is where it's good to study in a group with 3 or 4 people. Study on your own as well. But if you get together with 3 or 4 people and say, I've made up 5 examples. We'll do my examples, then we'll do your examples, then we'll do yours, and it really, really helps. You'll get better and better at this as you practice. And eventually it's very mechanical. Once you understand how the algorithm works, and it is an algorithm, Yates order is an algorithm. Once you understand how that algorithm works, you won't ever make a mistake. But it just involves practice and practice and practice. Oh, and by the way, don't worry, I will be posting things in the LMS for practice. Okay, let's try going the other way. you'll have to do this too. You'll have to go the other way. You'll have to go, and in fact, this is much more like it works in the real world. Very often what you get, back up, when I get an article to review from a journal, a lot of times I figure that they've chosen me because I know statistics. A lot of times they do, I think. And also everybody knows in my sort of research community that I'm a stats guy, so I don't want to be embarrassed by missing things that are statistics. So the first thing I do is I look at the design, and I look at usually an ANOVA summary table or just what they had for their if they have analysis variance, and I go from here and I rebuild it. I say, okay, the design should look like this, and if it doesn't look like that, they've likely made a mistake. And I have caught people. When I say caught, it's not like people are trying to cheat. People make mistakes. And I've caught people making mistakes and almost making fools of themselves in print. Because the other person reading it goes, I don't know. I got a C in stats. So when I'm reading it, I'm a lot more critical that way. So let's look at this. We have B, S within B, A by A by S within B. Let's do this. It's not that bad. So between subjects within, what are our between factors, or do we have any between factors? Yeah! I was trying to be cool, and I'm not cool. Well, you're simply not cool, and I should accept that at this point. 59 years old. There's no cool 59-year-olds, really? Really? Anyway, okay, so between subjects within, what are our between factors if we have any? I'm going to point to somebody in a second. So somebody just say something. Andy's sick, so I don't want to be mean to her. Pharaoh, what is the what's our? Do we have any between factors here?
B.
Yeah, that was easy. It's B. Because it's before subjects. I would never give it to you not in Yates order. I would always do that. Just the same way it would come out of a computer that way. So B is between. And how many levels does, B has 3 levels, right? Look at it, it's 2 degrees of freedom. So let's draw this up. B1, B2, B3. Oh, A seems to have 3 levels too, doesn't it? Beautiful. And we know, because Vera told us, that subjects are nested within B. It says that, and also we know B is a between factor. So we did it, Vera's right, because that's saying that. Beautiful. So that means we have different groups and different levels of B. 1, 1, 1. 2, 2, 2, 3, 3. How many subjects are in each group? There's a couple of ways to do this. There's an easy way and a little bit of a harder way. You want to know the easy way? Probably. 35 degrees of freedom. So how many total observations? 36. 36. Well, how many cells do we have? 9. 36 divided by 9 is 4. So n equals 4. Done. You okay? You said you're not okay or you're okay?
I'm not okay.
Okay. How many total observations do we have? Well, it says it right here. 35 plus 1. We have 36 observations, correct? Oh, wait a second. That's times 9. I'm not going to 36, right? Yeah. Okay. It's 9 cells. 36 divided by 9 is 4. So we have 4 observations in each cell. That's the easy way to do it. You can also look at this and go A by S. This is what I would do. I would do both of these things to make sure I'm right. Whoops.
Touch this in a while and it does that. Come back.
Okay. So A by S within B. Let's do this here.
Let's erase the board with the thing.
So A by S within B is 18. That says. So if A by S within B is 18, that means A minus 1 times N minus 1. Sorry, I'm doing that wrong. Isn't it? Yes. No, that's right. Yeah, a minus 1 times n minus 1 times b equals 18. And, well, b has 2, well, that's got 3, and that's 3 minus 1 times n minus 1 equals 18, and now solve for n. You could always do it that way. And I would do both, just to make sure I did it right. That's like, you can do it in your head, you have to always write it all the way out. But I mean, if you did it this way, and you go, okay, yeah, and 9 divided by 4, oh yeah, I got it. Or 9 divided by, sorry, 36 divided by 9, 4, okay, good. Okay? So you should be able to do that too. And like I said, that's a real skill, because when you're reading articles, sometimes, a lot of times, people will not show you a nice diagram of the research design. They will not show you A and then B. They'll just tell you, they'll describe it to you. And for me, when I'm reading something, I also like it just to have to draw out, like, what's the design look like? What do these people do? And if they've written a halfway decent method section, I can do that. And then I can go back and look at the analysis and go, okay, so the analysis says the same thing as the results section, they probably did it properly. Questions? All right. So remember a few things. First thing to remember is that using Yates order, you can figure out any design, the error terms, and degrees of freedom, and it always works. It's a beautiful thing. So let's go back to these weird research designs. I was working under the assumption that everything here is a fixed factor to use Yates order to figure out the error terms. Is hospital a fixed factor or a random factor? I think it's a random factor, probably. Because, like, I want to generalize to all hospitals, not just those 3. Kind of like when I talk about subjects, I want to generalize to all people, not just the people in the experiment. Wouldn't change how you test the drug effect, but it would probably tell you you couldn't test the hospital effect. And what does it even mean if you find a significant effect of drug in the hospital? You look at that and you say to yourself, oh, it means the drugs are different. And this is what happened with the guy I knew, Todd, who was doing this consulting for these people. He said, you found a difference between drugs. And they were like, yay. And he said, yeah, but it says within drugs within each hospital. So what that means is, if you were at Women's College Hospital using drugs 1 and 2, he said, like, do you see the problem? I had to mention the hospital they were at, and I shouldn't have to mention the hospital they're at. I should be able to say this drug is better than this drug. So he said, basically, guys, you've, I think the clinical trial cost $110,000 because they're expensive to run. And he's like, and you guys have no more money, right? Because you kind of have to do more, collect more data. So they went with this. Now, eventually, of course, I'm sure everything worked out. But the point is, if you're going to be, if you're not going to lie, if you're going to use statistics for good and not for bad, you're not going to try to convince people that this says something, you have to be honest about it and say that this means that drugs are different within each hospital. It doesn't mean drugs are different. It probably means drugs are different. This is a nice starting point to do another clinical trial. But it probably just means that drugs are, conservatively, just means drugs within hospitals are different, which isn't really what you were after. Right? So yeah, it was great, by the way. If you do get good, if you're good in stats, you get in grad school, get your name out there. You can charge ridiculous amounts of money. I did a bunch of chi-squared tests for a woman on her anthropology master's thesis. It was $500. Took me 20 minutes. And then her dad called me. This was the weird part of that one, by the way. Her dad called me. He's like, you can't do that. You gotta do it. It's the wrong kind of statistical test. I said, oh, really? Which kind would you use in this situation? Because I thought maybe I'm wrong. And the guy was an MD. He said, I've taken statistics. I'm thinking, not as much as me, pal. And I was a postdoc then. And he's like, I'm Dr. blah, blah, blah. And I said, well, I'm Dr. David Broadback. Well, you should do a t-test here. I said, how? How, pray tell, would you do a t-test on these counted data? Well, you look it up and you find a probability. I said, no. That's not, I know how they work. I know the calculus behind how they work. Can you explain to me how you would do a t-test on this? He's like, well, I said, yeah, see, I'm the expert here, so I did it right. Your daughter did a cool experiment or study. Anyway, you can make a little extra money. I'm just saying, get good at this. And sometimes in grad school, you need a little extra money. Avoid these designs if you can. I know one person who did it, my friend John. My friend John died a few years ago, so it killed him. He'd like that joke. He'd find that funny. So if you avoid these, it's good. The big thing today, that's the final bit. Well, I mean, we'll talk about lattice. We'll talk about lattice squares today. Maybe we will. No, we can talk about it today. What do you think? You want to talk about lattice squares? No. Well, I know you don't. I don't know why I said it that way. That came out horribly, and it wasn't meant that way. I mean, I like you guys, so I like to kid with you, and that really came out like I was being a really shitty person to you. I'm sorry. Because we can stop, or we can do some more examples. Do you want to practice some examples that might be useful, or do you want to just leave? Look at all you guys leave. I want to leave. Or do you want to do examples? I heard somebody say examples. You want some examples? Let's make some up. All right. So what I'm going to do is I'm going to stop these recordings because